needed to wrap up the improved formula. How much improved? Well, it's so much improved that we have to calculate 2 slopes instead of 1.
That sounds awful.
It is a little awful. But here's the idea behind it. It is, yeah. So here's your function, f of x. And here's a point, x naught. Yesterday we talked about how, you can find the tangent line slope and then use that tangent line to approximate the output of the function at x1. So that gets us here. Okay, obviously there's a bit of error between the output of x1 versus what the actual output is at f of x. Okay, so what we want to do is get closer. We want to get as close as possible to that. That's the goal. Okay? So, what Euler decided to do was use the tangent at x1, apply that down here, and what essentially you're going to do is average the slope of this tangent line, the slope of that tangent line, which creates this like intermediate slope, which gets us a little closer to that output. That is awful. But we're only going to do half of it, so it's not a big deal. Here's the formula, and I'll explain what everything is in a second, okay? So to calculate the next output, you take previous output plus step size, and now here's where I was talking about you take the average of the slopes of the tangent lines. So you take f of x sub n, y sub n, which would be the slope of the original tangent line at x naught, plus, now you take the next x value, plug it into the slope formula for the differential equation, and you're going to also use what we call y sub n plus 1 star, which I'll define in a second. We take those 2 tangent line slopes, we average them, and then that gives us like an average slope, and then that's going to give us our output, which will be a little bit better than the previous method. Okay? Now, y sub n plus 1 star is simply calculated using regular Euler's method. You do y sub n plus h f of x sub n y sub n. Okay, so basically you start out by doing Euler's method the way we did yesterday. You get that slope, and then you're going to use that, plug it back into the formula to get a new, what the next slope would have been, average that, and then plug it into the formula.
So not improved as in easier?
No, improved as in more accurate, not as in less work. Let's take a look at an example. So let's take a look at y prime equals 2xy as opposed to 0.2, which is what we did yesterday. Let's go ahead and find y of 1.5 given y of 1 equals 1. Step size is 0.1. 0.5. That would have been nice. Okay, So, x sub n, y sub n. We start with x is 1, y is 1. Now to figure out the next y value, first we have to figure out y sub 1 star. Okay, once I know y sub 1 star, then I can use the improved formula. So y sub 1 star is y naught plus step size, and then you plug in the coordinates x and y into the slope they gave you, which is 2xy. So 0.1 times 2 times 1 times 1. We get that y1 star is, and by the way, this is 1. So 1 plus 0.1 times 2, 1.2. Okay. So then now we're going to go ahead and find the actual approximation for y1. So now this is where we use the improved formula. So previous y value is 1. Step size is 0.1. And now we do the average. So we do 2 times 1 times 1, because we're just plugging in the previous x and y values into the slope, which was, again, 2xy. So we have 2 times 1, plus 2 times, what's the next x value? 1.1, and then the next, well, it's not the next, we're trying to get the next one, but we're using this y1 star value, which was 1.2. Take the average of those, multiply it by the step size, add 1 to that. You get 1.232? Okay, take your word for it. We'll do one more for good measure, and I think you guys get the hang of it. y2 star, previous y value is 1.232 plus step size 0.1, and now we plug in 1.1 and 1.232 to get y2 star. .50304. Okay, and then once we have y2 star, we can get the next y value. You can see why I'm only asking you to do half of what they said in the book, right? I mean, if you want to do the whole thing, knock yourselves out. y2 would be y1, which was 1.232 plus 0.1. And now we do the average of previous point plugged into the slope, which was 2 times 1.1 times 1.232. I'm running out of space, but you get the idea. Plus 2 times next x value is 1.2, and then our y2 star value is 1.50304. You take all of that, divide by 2, and does anybody have that? No? 0.1. Let's just do it. 2 times 1.1 times 1.232 plus 2 times 2 times 1.5. Is that what you guys got? Well, you could have told me. 1.5479 or so. And so on and so forth. You get the idea. Yes?
So since we're doing it on the calculator, I don't want to show every calculation or just like one sample calculation?
Oh,
I mean, if you kind of know how to do the recursive stuff on here without having to write, I mean, like I said, show me a couple so that I can see that you know what you're doing. And then if you have the table filled out correctly, that's good. Yeah. Anything else? If you decide to create your own program, which I had someone try to do last year, but they programmed it wrong, make sure that it's right. And make sure that you tell me you're using a program. You might even want to show me the program to make sure that it's working properly. A student last year decided to create a program. They're like, oh, yeah, I got it. It works perfectly for both. And I said, oh, okay. They never showed it to me. And then in the exam, they said, use my formula, or my program. And they were, like, completely wrong. And I had no choice but to what? Give, like, 0 points for it because there was no work shown at all. Okay, so I encourage you to do so, but make sure that you actually do it right.
If the program is right, he didn't like show anyone if they got the right answer.
Mm-hmm.
Yeah, that'd be fine.
Yeah, I mean, if you know how to use your calculator, use your calculator.